Assalamu alaikum. I am Nusaiba Thesis, currently working as a lecturer at the Institute of Water and Flood Management, BUET. I completed my undergraduate studies from the Department of Water Resources Engineering, BUET. I conducted my BSc thesis under the supervision of Professor Mohammad Mustafa Ali Sir, and I will be presenting the findings of my work. The title of my thesis was Studying the Impact of Itnamitamoi-Noshogram Road on the Flooding Pattern of the Northeastern Region of Bangladesh using HEC-RAS 1D 2D coupled mode. This is the outline of my presentation. The northeastern region of Bangladesh is frequently affected by flash floods due to its hilly topography and steep slope of the rivers. Haors are seasonal wetlands that are a predominant feature of the northeastern region. The Haor areas are very important for boro crop production in the pre-monsoon season. However, in recent years, early flash floods are threatening the production of boro crops. In June 2022, this region experienced its worst flood of 30 years. From the Lancet image analysis of 2022, we can get an idea of the flood arrival. In March, most of the area remained dry. The floodwater started arriving in April, which started spreading in May. By June, almost the whole region went underwater. In recent years, a lot of roads have been constructed in the Haors, which has been identified as one of the possible reasons for the delayed flood recession. So in my study, I selected my study area near Nikli Haor of Kishoreganj Upazila, where the Itnamitamoi-Noshogram Road, also known as the All-Weather Road, was constructed in 2020. The road passed through the Haor body and is situated in between a river system consisting of three main rivers, Donu, Kalni, and Upper Meghna. The length of the road is almost 29.73 kilometers. Through my study, I tried to assess the impact of the construction of this road on the flooding of this region. In this slide, you can see my selected study area and the Itnamitamoi-Noshogram Road and its location. So here are my three major objectives: to set up a 1D 2D coupled hydrodynamic model to simulate inundation for the selected study area, to analyze the impact of the Itnamitamoi-Noshogram Road on the flooding of the study area, and to evaluate the changes in inundation under different road opening conditions. This is my work methodology. I collected data from both primary and secondary sources. I will discuss the details of them in a while. I incorporated all the collected data to set up the 1D 2D hydrodynamic model, and for my study, I used HEC-RAS. Manning's N was my calibration parameter, and after both calibration and validation of my model, I simulated various scenarios for my study area. I looked into the general inundation pattern of the region, the inundation condition after the construction of the road, and then simulated the inundation for various road opening conditions. I collected the road parameter data from a field visit to the study site conducted in October 2022. The main required parameters for my model setup was the elevation of the road, the locations of the road openings, such as the bridges and culverts situated on the road, and the width and length of those openings. I also collected secondary data, such as the water level and river bathymetry from BWDB, the topographic data, the SRTM-DEM from USGS, and digitized the road shapefile from Google Earth Pro. For setting up the model, I first developed the 1D river system with three main rivers and a junction in the middle. There were two upstream and one downstream boundary. And for the surrounding floodplains, I generated a two-dimensional grid of 200 meters. For the coupling of the 1D and 2D setup, I used lateral structures. Structures of varying lengths were used along the rivers to connect the river system with the flow area to ensure water flow from the river to the floodplains. On the right, you can see the 1D 2D coupled model. Finally, the road was set up as a weir, and the road openings were manually incorporated into the model. These openings were later modified to simulate scenarios with varying road conditions. In the slide, you can see the weir with existing road opening conditions. With the incorporation of the road, the model setup was complete. After setting up the model, I calibrated and validated the model, tuning the Manning's N. The calibration was done at Khaliajuri station and the validation was done at HEC-RAS station for the same time period. The simulated water levels closely matched the observed data and yielded satisfactory values of coefficient of determination. The final selected values for Manning's N were 0.025 for riverbed, 0.035 for the banks, and 0.05 for the floodplains. Now coming to the results. I prepared a flood inundation map for the existing condition of the study area with the road. I then compared the inundations generated with and without the road. It was clearly noticed that after the construction of the road, which we can see on the right side of this slide, the inundation in the upstream area of the road increased significantly. Considering the model without the road as 100% opening, I later compared the total area of inundation and percentage inundation for different road opening conditions. The existing opening of the road is only 5.73% for the 29-kilometer long road. If the opening can be increased to 10% or 25%, the area of inundation might decrease by 5% and 18% respectively. Comparing to the no road condition, the road was observed to be increasing the inundation percentage by almost 3.28%. This plot gives us a clear overview of the impact of the road openings on the inundation extent. With increased road openings, a decrease can be observed in the total percentage of inundation. While also comparing other parameters of inundation, an impact on the flood depth and duration was also observed. The floodwater can be observed to be rising in beginning of July when the road was not there, whereas the water starts rising mid-June with the road being present. This indicates a 15-day increase in the flood duration, which can be reduced to some extent with increased road openings. The flood depth was also observed to rise by almost 0.5 meter. To conclude in short, the total inundation area increased by almost 103 square kilometer because of the construction of the road. With an increase in the road openings, the total percentage of inundation was observed to be decreasing. And after the construction of the road, the flood duration increased by almost 15 days and flood depth increased by almost 0.5 meter. There were a few limitations of my work that can be addressed in the future. More precise and recent topographic data can be incorporated for better model performance. Other minor rivers around the study area can also be incorporated to check their impact. And hydrologic processes such as precipitation, evaporation, and transpiration can also be incorporated into the model to improve the results. Also, a detailed economic assessment can be conducted to evaluate the feasibility for different road opening conditions. Here are a few references that I have used for my study. And that concludes my presentation. Thank you so much.